Volume of a cylinder. Excellent. What is the values of a cylinder? It's the area of the base multiplied by the height. Thank you. And if the area of the base is a circle, then how do I replace this? What is the area of a circle equal to?
Pi r squared.
Excellent. Pi r squared h. Very good. Awesome. So I have the equation. But I have the equation that connects V, R, and H. I don't want this equation, but that's my starting point. That must be my starting point. But I want an equation that relates or that has their derivatives. Which of these does not change? Or they all change? With time. I need to establish which ones are variables and which ones are functions of time. Do they all change with time?
The radius doesn't change?
Excellent. So the radius is 25 because it's squared. Awesome. So then V equals 25 pi h. So I'm going to put a dot underneath V because it's a function of time, and I'm going to put a dot under h because it's a function of time. And now we're ready. Ready for what? What are we doing next? Something we learned in this chapter. What am I trying to do now? What should I do to this equation? What is the next step?
Differentiate?
Yes, very good. Good. So can anyone differentiate this equation for us? The left-hand side and the right-hand side? Anyone? It's okay if you're wrong. Just any thoughts? What do I write when I differentiate this with respect to time? So these are functions.
dv dt.
dv over dt, of course. 25 pi. And let's differentiate this with respect to time. What do I write?
dh to d.
That's it. I have everything. I have this as 3. All I'm asked to find is this. So dh over dt equals 3 over 25 pi. I can approximate it, and I will. So I'll punch it in the graphing calculator. Be very careful how you do that. So the top is 3. Divide by, if you do not write parentheses around 25 pi, you will get something else. The same thing you will get if you remember to divide 3 by 25 and further divide by pi. Then you will get the same thing. But be careful if you divide without parentheses, you just keep multiplication symbol, you're not going to get the correct answer. So this is approximately 0.0382. The exact is this. So this is exact. And this is approximation. Okay, we need to establish the measurement unit, and we can move on to another problem. They're getting more sophisticated. Can anyone give us the measurement unit?
Is it meters per minute?
Of course. Oh. Of course. Meters per minute. Great job. Okay, so let's continue with another. Any questions? Any questions, please, for me? Do we have any doubts about this? Any doubts? Any questions? Okay, I'm sharing my screen. That's not what I wanted. I wanted this. Okay. What about number 12? A particle is moving along a hyperbola. So we have xy equals 8. As it reaches the point 4, 2, the y-coordinate is decreasing at a rate of 3 centimeters per second. Decreasing means I have to put a negative 3 centimeters per second. I have to stop. So as it reaches this point, the y-coordinate is decreasing at the rate of. What does this represent? I need to be able to dissect each and every word, be able to understand what it's asking me to do.
dy dt.
Excellent. Excellent. Great job. Y because it's a length, T because it's seconds. Awesome. Thank you. We are getting there. It's something new. It's something different. So we need patience. How fast is the x coordinate of the point changing at that instant? And then I'll come back. As it reaches this point, okay? So that's a little trap. So that's the trap. That's the when. That's the if, blah, blah, blah. That's the trap. Okay, the 4, 2 is our trap. I'm going to write it here, or pay attention. Okay, so let's identify what is hidden in the question. How fast is the x coordinate at that point changing, of the point changing at that instant? So what is this asking us to determine? You need to see it again?
Yeah, please.
Sure. How fast is the x coordinate of the point changing at that instant?
With dx dt.
Very good, of course. And I will write here when x is 4 and y is 2. This is the trap. This cannot be used. It's not something like it's carved in stone, like here. The radius of the cylinder was carved in stone. I had to use it. This is not carved in stone. The particle is moving. And I want to determine this rate of change when this is a trap. Okay? I have to determine a relationship. I have to determine the derivative. And when I find this, then I can plug in what they want me to plug in. Okay? So we start with a graph, a figure, something. So I have xy equals 8. What does this doesn't mean much to me, but y equals 8 over x does. So if I divide both sides by x, I know how this looks like. It's something like this. We know how 1 over x looks like. It's embedded in our brain. So 8 over x is not too different. Okay, so this is 1 over x. Very similar, 8 over x. Not a big deal. So I know that the particle is moving along this curve. Moving, 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 moving. Okay, fine. So I know the equation. Y equals 8 over x. I know that y is a function of time. I know that x is a function of time. That's why I put those dots underneath. I have the equation that relates y and x. It's given to me. I don't have to come up with it. So this is a nice situation. I have it. What should I do? So here I had to come up with this and then differentiate. But here I don't have to. I already have it. So what do I need to do next? What is my next step?
You plug in 4 and 2.
I cannot. I'm asked to find a relationship between these two, and then
Can you use the product rule?
you can, but why? There is no need. The left-hand side is dy over dt. What did we say we carved in stone? What was 1 over x prime equal to? This is a super important relationship, or property if you want, or derivative if you want. So what do I write? We shouldn't be thinking of this. This should be on the tip of our tongues forever.
Negative 1 over x squared.
Negative 1 over x squared, because this is a function, then I have to say something else. Good. So can anyone differentiate 8 over x? 8 in front. What next?
Like the actual derivative of it, wouldn't it be negative 1 over x squared? So negative 8 over x squared.
Function of time.
D of x over dt.
Very good. That's why I put the dots, so we don't forget. So dy over dt is 8, negative 1 over x squared times the inner function prime, dx over dt. Now the when comes into play, not before. Don't touch it. It's the when, or if, or when, or knowing that, blah, 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 so to speak, right? So now dy over dt, when x is 4 and y is 2, that's fine. Negative 8 over x squared, 16, times dx over dt, dx over dt, I have to solve for dx over dt. dy over dt is given to me. I need to solve for dx over dt. dx over dt, and dy over dt is given to us as negative 3. So we are solving this equation for dx over dt. So multiply by, so when I simplify, I only need to multiply by 2. So dx over dt equals 6. Measurement unit. We have to make sure that all, let's look again for a second. So centimeters, yep. So all dimensions are given in centimeters. We are not told anything different. So what is dx over dt? Equals, what is the measurement unit of dx over dt? We really shouldn't be thinking, because it has to be these two measurement units.
Yeah.
Meters per second.
That's it. Brilliant. Perfect. Okay, we're getting there. Any questions on this problem? So I highly recommend, before you start differentiating, you don't have to use the dot, use anything else, highlight or something with a marker, whatever you want to do. So you can also do this, right? Just highlight that these are functions so you don't forget, times the inner function prime. Okay? This happens here because it's in the denominator. How come that I didn't have anything here? Yeah, that's because that's the function, dy by dt. But this is in the denominator. So I have to use the formula, negative 1 over x squared, Ada's outside is a constant, doesn't matter, times the inner function prime, dx over dt, by the chain rule and the power rule together. And it makes sense. Look what happens. When it's here, 1, 2, 3, 4, 1, 2, whatever. Of course, my measurement unit is not good. Obviously, x is increasing, but y is decreasing. So dy by dt is negative 3 centimeters at this point, negative 3 centimeters per second, but x, dx over dt is 6 centimeters per second because it's increasing. Okay, so let's continue.